Welcome to another video. In today's video we are going to solve number of recent calls problem from the Leetcode. In this problem we have to find out the number of calls which are made from interval t minus 3000 till t. So we have to find out how many calls were made in this range. Each call is made with a certain time and every call will be made in increasing order. So that's what the problem statement specifies here. So we just have to find out how many calls are there in the range of t minus 3000 to t. This is the basic statement for our problem. But how can we solve this problem? One way to solve this problem is we can store every call as it comes through in an array, and for whenever a call happens we can just go through the array and find out how many calls were made in this range and we can return that count. But as the number of calls increases, it becomes a huge array and we have to go through every element in the array. We don't want that. We only need data about calls which are made in this range. Which data structure we can make use to get this result? One way to do that is we can make use of a queue data structure. In a queue, elements will be stored in the order in which they are entered into the queue. We are going to maintain a queue for time in which a call is made, and whenever a new call is made, we have to remove the calls which are not in this range because they are no longer needed for our further queries. This will greatly reduce the time that we have to go through to find out all the valid calls which are in this t minus 3000 to t range. How can we solve this problem? Let's go through one example so that we can understand how this solution works. Initially queue will be empty and let's say the first call happens, that is at time 1. Since the queue is empty, we are going to insert that time into our queue and answer becomes the size of the queue, because at every point we are going to store only valid calls in the queue. If the time is not in the range of t minus 3000 to t, then we have to remove those calls from our queue. And let's say another call happens, 100. Now also we will check if anything can be removed. If there is any call which is not in the range of t minus 3000 to t, then we have to remove. The current time is 100 for the second call. Now time is 100, and is there any call which is not in the range of t minus 3000 to 100? This is what we have to find out, and if there is any such call in the front of the queue, we just have to keep removing it because it greatly enhances our solution. Since there are no such call, one is within this range, we just have to insert the new call into our queue. Now the size of the queue is 2, so after the second call the answer is 2. The first answer was 1, which is represented here, and the second answer was 2, which is represented here. Let's say another call comes, 3001. Now the t is 3001. For this third call, t is 3001 and t minus 3000 is 1. So we have to remove if there is any call which is made which is not in this range, 1 to 3000. Since all the calls which are already present in the queue are already within this range, we don't remove anything. We just insert our new call here, 3001. Size of the queue becomes 3. So then there are 3 calls are made within the t to t minus 3000 range. So answer will also become 3. Now for the fourth call, t is 3002 and t minus 3000 will become 2. So if there is any call which is not in this range, then we have to remove that from our queue because it is no longer valid. Now if we come to the queue from the front of the queue, this call 1 is not within this range. So we will remove that from our queue, and 100, 3001 are in valid range, and after that we have to insert the new call, that is 3002. So the size of the queue becomes 3, that is the valid number of calls which are made in the interval from t to t minus 3000. This is how we are going to solve this problem. In the constructor we are not going to do anything, but when a ping comes, what we need here is we need a queue. As discussed in the solution, we need to have a queue to store all our recent calls which are made. So what we are going to do is we are going to declare a queue which will going to store all the calls, recent calls which are made in the range of t to t minus 3000. And constructor we don't do anything, but whenever a ping happens we are going to check if queue is empty. If queue is empty, we are going to push the recent call into the queue, and otherwise we have to check if there are any expired calls. So while if there are some elements in the queue, that means queue is not empty, and if there is a call, if queue.front is less than t minus 3000, then that call has been expired. We have to remove that call from our queue. We have to do this for all the numbers which satisfy this criteria, and finally we are going to push it to the queue. Now finally we can return queue.size. Let's run the solution and check whether it passes all the test cases or not. As you can see here, this is passing the first test case. Let's submit the solution and check whether it passes all the test cases or not. I think we can do some optimization here. Since we are doing the same thing, I don't think we have to do this separately. We can directly write it like this. First we are going to check if there are any expired calls, and then we will push the current element. Let's check whether this solution passes all the test cases. Yes, as you can see here, even this solution is passing all the test cases. What is the time complexity for this solution? Time complexity is in the order of O of n, because there can be n calls which are already present with a time interval. Let's say if every call happens within 3000 interval, then time complexity is O of n, and even space complexity will be O of n during that case. I hope you like this solution. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.